Hello everyone and welcome to ixamBee, where we help you to prepare 50% faster. Continuing with our revision series, today we are going to discuss some important MCQs on hashing and collision resolution. So here is the first question. There are certain keys that are given and they are inserted to the hash table of size 9 using the hash function kmod 9. You have to say how many collisions have occurred during the insertions of these keys into the hash table. The answer here is D, which is 4 collisions. Here you see that 72 would get inserted at the 0th index. Then 2736 will give a collision. 24 will get inserted, but 63 and 81 will again give a collision because they are divisible by 9 and the 0th index is already occupied by 72. In this next question, using linear probing with hash function kmod 7 and table size as 7, you have to insert the given keys in order and then you have to find the final position of key 73. The answer to this question is B, 4. Here you see how the keys are inserted into the table. So 73 gets the position which is 4. Let us try to track this. 50 will be divided by 7 and it would give the remainder 1. So it will occupy the index position 1. Then comes 700, which gets the index position 0. Then 76. 76 will get the index position 6. And 85. 85 will give a remainder of 1. So it is going to give a collision, and since it is linear probing, it will occupy the index 2. Similarly, 92 will also give a collision, and since it is linear probing, it will occupy position 3. When it comes to 73, it again gives a collision because 3 is the remainder when 73 gets divided by 7 and that position is already occupied by 92. Hence 73 gets to position 4 and that's the answer. In this question, using hash function kmod 10 and quadratic probing, key 89 is inserted. Slot 9 is occupied. So what is the next probe location where probe I value is given as 1? Here the answer is A0. It is going to be calculated as 9 plus 1 square mod 10. We are doing 1 square because the probe value I is given as 1 and we are using the quadratic probing. So finally, we would have 10 mod 10 which is equal to 0. In this next question, a hash table of size 7 uses double hashing with the first hashing function as k mod 7 and the second hashing function is 1 plus k mod 5. For key k is equal to 14, if h1 of 14 is occupied, what is the next probe index? The answer to this question is D5. H114 is calculated as 0. So it is said that it is occupied. So H214 would be 1 plus 14 mod 5, which is 5. So the next probe would be 0 plus 5 mod 7. And that will give us the value 5. In this question, you are asked that in a hash table using linear probing, the average successful search time with load factor alpha is approximately what? So you are given a lot of formulae here. You have to select the correct formula. The answer here is A, which is 1 plus 1 upon 1 minus alpha, and this entire thing has to be divided by 2. This is the Knuth formula for average successful search with linear probing. Next, we have a hash function which produces values in the range of 0 to 99. If the table has 100 slots and 50 keys are already inserted, the probability of collision on the next insertion would be what? That is what you have to tell. So since 50 keys are already inserted, the probability of collision on the next insertion will be 0.50. So the answer is B, 0.50. In this question, keys 5, 10, 15, 20 and 25 are inserted into a hash table of size 5 using the hash function kmod 5. All keys map to slot 0. How many probes are needed to insert the last key, which is 25, using linear probing? Here, the answer would be D5. Here, all the keys are mapped to slot 0. So, in order to get a space for 25, we will have to probe it 5 times, and on the 5th probe only, we'll get a place to store this value, which is 25. In this next question, a hash table of size 10 is using a hash function kmod 10. The keys inserted are 44, 45, 79 and 55. With linear probing, you have to tell what is the slot of key 55. So the answer to this question is B6. 44 is going to be mapped at the 4th index. 45 will be mapped at the 5th index. 79 will be mapped at the 9th index. When it comes to 55, it will be creating a collision because the 5th index is already occupied. Hence, with linear probing, it will occupy position 6. In the next question, in separate chaining, if n is equal to 1000 keys are inserted into m is equal to 500 slots, what is the expected number of keys in each chain? So here the answer is C, which is 2.0. The load factor alpha is given by n by m. So here n is given as 1000 and m is 500. Hence the value 2.0. In this next question, we have using a hash function kmod 11 and quadratic probing, key k is equal to 20 must be inserted. Slot 9 is occupied. Slot 9 plus 1 is equal to 10 is occupied as well. Where does 20 land on probe I is equal to 2? The answer to this question is A, 2. Here we are using quadratic probing. So it is the second probe. So we will be using 9 plus 2 square mod 11, which gives us 9 plus 4 mod 11, which is 13 mod 11, which is calculated as 2. So with that, we come to the end of this video. These were some probable questions that may come in the IBPS SO IT examination in relation to hashing and collision resolution. Be sure that you have understood all the topics of hashing and collision resolution strategies. Have a wonderful learning experience with ixamBee, and thank you for watching.